Hello there, my name is Gary Sims and this is Gary Explains. If you've been following me on Twitter, you'll have seen that picture I posted showing I got hold of a Rock 5B. Single board computer, octa-core processor, 2.5 gigabit Ethernet. It's got an M2 slot on the back so you can put in NVMe storage. Now, this is not a sponsored video, so if I do seem enthusiastic, don't write in the comments like some child, oh, this is a sponsor. No, it's not a sponsored video. I really am enthusiastic about this. This is a Raspberry Pi 4 killer. Almost. It's almost a Raspberry Pi 4 killer. There are some wrinkles. So if you want to find out more, please, let me explain. Okay, so let's start to take a look at the board. This is what it looks like from the front side. As you can see, most of the ports, the big ones, are along the one edge. You've got the pins, the GPIO pins on the other edge. Of course, here, the star of the show, the Rock chip processor. We'll talk more about all these things in details in a moment. Let's flip the board over. And the big thing here is you've got this M2 M key, which means you can put in an NVMe SSD storage in there, and you would screw it in using that little holder there. And here, just notice, you can see all the labels there for those ports, which is about 2.5 gigabit Ethernet, USB 3, USB 2.1, HDMI, and so on. Again, we'll go into all of those in a minute. Now, here is a nice kind of sort of advertising about the board, kind of in Apple style, what they've kind of done for the Macs over the last few years. It's the Rock 5 Model B. What have you got? Well, you've got up to 16 gigabytes of memory. The one I'm testing is an 8 gigabyte version. You've got the ARM Mali G610 MP4 GPU. You've got an NPU. The actual Rock chip 3588 is an octa-core. This is important, it's octa-core. So the Raspberry Pi 4 is a quad-core, it's an octa-core. You've got 4 Cortex A76 and then 4 Cortex A55 cores. It supports up to 3 displays. There's 2 HDMI ports on there, but also the USB-C can display through that as well. You've got HDMI in port. Now you've got PCI version 3 4 lanes of NVMe there. You've got 2.5 gigabit Ethernet, as I said, USB 3.1. You've got an M2E key for things like wireless adapters. There's an eMMC socket, and going back to the displays here on the right hand side, it says it can display up to 8K. So the first thing, of course, with that processor, I wanted to look at the performance. So this is using my thread test tool. The source code is available in my GitHub repository. We've got single-threaded and multi-threaded scores here. So if we go across, the Rock 5B single-threaded is 0.5. So the lower, the faster it does it, the better. Compare that to a Raspberry Pi 4, which has got 0.77. So that's the difference in the Cortex A72 and the Cortex A76, and the difference in clock speed between the Raspberry Pi 4 and the Rock 5B. If you take something like Project Volterra with the Snapdragon 8CX, that does it in 0.356, so even faster still. If you go to something like the Vision 5, which is a RISC-V CPU, well, that's just hugely different. Look at that, 2.94. Completely in a different league in terms of slowness. And interestingly, you know, people talk about, is the Rock 5B a replacement desktop computer? No, it's not in general, but of course, definition of what is a desktop computer is of course very broad. If you were to buy one of these cheap mini PCs with a J4 125 Celeron processor in it, which came out only in 2019, this processor is not an old processor, you can see there that, look, it's 0.7, so it's about the same speed as the Raspberry Pi 4. Of course, if you go with an i7, you know, with 12 threads and 6 cores, you know, whatever it is you can get, different scores completely. I absolutely understand that and agree with that, but of course, it just depends on what you define as a desktop computer. Now, moving on to more benchmarking I did, I've got my sublec compiler test. Again, the source code is available in my GitHub repository. If it's faster is better. So the Rock 5B comes in at 13.59 compared to the Raspberry Pi 4, which is 25.79. This is single-threaded score, by the way. 10.7 for the Project Volterra, 47.1 for the RISC-V based Vision 5. And again, back down here for a J4125 Celeron processor 15.7. So you can see that the Rock 5B is basically the winner, except for the Snapdragon 8CX Gen 3, which you've got in Project Volterra. One more final set of tests here between just the Rock 5B and the Raspberry Pi 4. This is my thread test tool using software only SHA-256 hashing, so there's no hardware acceleration. Again, the source code is in my GitHub repository. 7.3 for the Raspberry Pi 4, 4.05 for the Rock 5B. So again, a significant difference. Lower is better. And for multi-threading, of course, nearly 30 there versus 10. Of course, is a quad core versus an octa-core plus faster cores, etc. So all the way across, of course, the Rock 5B beats the Raspberry Pi 4 hands down. It's not even close in many cases. So here's a question for you. Do you have a case on your smartphone? If you do, is it thick and bulky? I'd like to recommend to you Phoenix smartphone cases. They're super slim, and you'll find a link to them in the description below. It's an affiliate link. If you buy through that, you help out this channel. Now, when it comes to software, there are some downloads available from the Radxa website. You've got Android, you've got Debian, you've got Ubuntu, you've got Reborn OS, and you've got Slam, which is an unofficial build of Slackware. And I did try out Android and Debian and the Reborn OS, and we'll talk more about those in a moment. Now, the big star of the show, as far as I'm concerned, that makes the Rock 5B even better, not only just in terms of CPU performance, but this one thing that makes it so useful is the fact that it has this NVMe M2 slot. So you've got 4 lots of PCI V3, and I plugged in a card that I've got, an SSD there. Of course, it does depend on the SSD, but here are some of the numbers I've been getting. Sequential writes for a 2 GB file, 422 megabytes a second. Sequential read of a 2 GB file, 3.8 gigabytes a second. So it read that file very quickly. I'm sure there's some caching going on in there as well. And then random 4K reads, 660 megabytes a second. So you can see this is pretty good storage speeds you're getting here, particularly considering that it is a single board computer. So this really does change everything for people who are running single board computers. You can have mass storage, fast mass storage, and you can even boot from the NVMe2. So let's emphasize that. No more SD cards. Repeat after me. No more SD cards. I mean, the fact you can boot from the SSD card there is absolutely fantastic. I did it. I tested it. It works absolutely fine. How do you do it? You attach the NVMe SSD into the M2 slot, screw it down, etc. You boot the Rock 5B from an SD card, which you've prepared beforehand. Basically, you copy over the image using a program like Etcher, as you would do with just about any single board computer. You download the compressed OS image file that you've just booted from the SD card, but you download it again and put it onto the SD card as an image file, probably image.xz in fact. You use xzcat, which decompresses it, and dd to write to the SSD. You download the latest firmware and firmware tools. You install the firmware. All the instructions are on the Radxa website. I followed them through, didn't hit any problems at all, exactly as they're right there. That's exactly what you've got to do. You shut down, you remove the SD card, and then you boot up from the NVMe, and it works absolutely fine. And here's a little screenshot showing from listing the block devices. I've got no SD card in there, just got that device there, and that's with my root partition on it. And so you can actually finally at last have your root partition and all your boot stuff on an actual proper SSD, a proper mass storage there. It's absolutely fantastic. Oh, it just makes me so happy to see this. Now, the Rock 5B has a 40-pin expansion header, GPIO, general purpose input output. The layout is exactly the same as the Raspberry Pi. So, you know, top right here, you've got 5 volts, 5 volts ground. On the left there, you've got 3.3 volts and the various ground pins and so on, but different pin names. So if you are used to doing something on a Raspberry Pi, you're going to have to make sure you translate to the pin names correctly on the Rock 5B. Now, the sad thing is there's limited library support at the moment. If you want to kind of do things at the moment, I was really doing it, you know, using the Linux kernel, accessing different files in the file system that are linked to these different GPIO pins. Couldn't even really find a Python library, certainly not a C or a C++ library. We'll talk more about that in a minute, but here is a shell, a program that I wrote to flash an LED on and off. What you pick the pin number 107, that actually happens to be the bottom right hand pin. This is the directory where all the stuff is going on, sys, class, GPIO, and then GPIO, and then the pin number. What you do is you have to write the pin number to this file export, which creates this directory and allows you then to change the values. You tell it it's an output and an input, and then I've got a loop here which goes around writing 0 and 1 to the value inside that directory there, with a sleep in between, so you basically flash the LED on and off. I'd just like to remind you can follow me on Twitter and other social media networks. All the handles are here on the screen. Also, don't forget I do have a monthly newsletter. Go to GaryExplains.com, type in your email address, no spam, but you will get the newsletter. Now, other parts to the Rock 5B besides the CPU and the NVMe slot is you've got GPU, NPU, and codecs, and we're going to look at all of those now. From when I was testing Debian, there is no GPU acceleration that I could find. I haven't tried Ubuntu, for example, to see if it's different in that. And here's a listing from one of the GLX info programs, and it just shows you here LLVM pipe means it's software rendering, and it says accelerated no. So software only rendering there on Debian, and I don't know whether there's going to be any support or not. That I just don't know. And the NPU, of course, that's an important thing to have. It's not something you find in the Raspberry Pi 4. It is something, of course, you find in other things like the Jetson Nano and the Jetson range in general. Of course, that's why NVIDIA are selling them. Now, there is this RK Rockchip NPU GitHub repository. It does provide an interface to the NPU, and I've seen various articles on the internet of people reporting using things like OpenCV, CV for computer vision, with the Rock 5B, and they get improved frame rates when the NP is being used. So if you're into doing the NPU, it looks like you can do it and it can be used, so that might be worth exploring if that's the things that you are into. Now, it does say there are hardware accelerated encode and decode. You can see here it's got an 8K video encoder, H.265 and H.264. It's got an 8K 10-bit HDR video decoder for 265, 264, VP9 and so on. So that all sounds great, but I couldn't find much way of getting it to work. So no support in FFmpeg. GStreamer support apparently exists, but I couldn't see how to get it working. In other words, I couldn't test it. So if you're into doing encode and decode, if you're doing transcoding, then this might be a bit tricky on this board. Although the hardware supports it, the software isn't ready, and that's really something you're going to hear me say quite a lot through the rest of this overview of the Rock 5B. Now, I maintain that the Rock 5B killed the Raspberry Pi almost. It didn't actually kill it, it almost killed it. Now, why almost, and what's wrong? Where is the weaknesses? What are the weaknesses? Why didn't this actually succeed in just being the de facto replacement for the Raspberry Pi 4? Well, there's a number of reasons. First is some people won't like the price. Now, it's $159 for the 8GB version. That's the version I tested. And it's over $200 for the 16GB version. Now, there is a cut down called the Model A, which has got some different limitations on it, some different changes. That's got 4GB of RAM. You can get that for $79. Now compare that to a Raspberry Pi 4 with 8GB, that's $75. So even the cut down version with 4GB of RAM is more expensive than a Pi 4 with 8GB of RAM. But, and this is a big but, you do get what you pay for. So first of all, you've got a much more advanced processor. So it's octa-core with 4 cores. It's A76, not A72 like you get in the Raspberry Pi 4. You get 8 cores rather than 4 cores. This is really the big thing for me. I've already said it. You may have noticed you've got the M2 NVMe slot. You can boot from it. You've also got support for eMMC. There's a little connector you can put there on the bottom of the board. It supports up to 3 monitors, and you get 2.5 gigabit Ethernet. So these are all incredibly good points that are going to cost you a bit more extra money, but could definitely be worth that extra money. And here's another big one. At the time of making this video, I'm sure this will be not quite the case if you're watching this video at a different time, but in February of 2023, you really can't buy a Raspberry Pi 4, but you can buy a Rock 5B. So if you're desperate to try and find a Raspberry Pi 4 and you can't find one, well, then the Rock 5B is certainly available. And to put it into context of the greater scheme of things, a Mac Mini or a Windows on ARM box like Project Voltaire will cost you at least 4 times as much. So although people are, they compare downwards in price, if you go upwards, okay, this thing is an absolute steal. 8 gigabytes of memory with an NVMe slot. You can put an SSD in there, 2.5 gigabit Ethernet control, 3 monitors, only for $150 something. That is an absolute steal if you compare it to what's above it in the price range. But ignoring the price, let's say you've got the money to buy this, there are some problems with the software, as I've already hinted about. So, for example, there are some bugs which, in fairness, yes, they will probably get fixed in the due course. But as I made this video, there are these bugs. So, for example, artifacts around the windows. When I move a window around the screen, you get some little blocks, funny blocks appearing. There's like when you try to install things using apt, then you get this whole thing about the radx repository isn't signed. Let me just show you that down here at the bottom, saying it's not signed, so it can't be used, and so on and so on. Okay, and also I tried Android, the Android build that's available. I couldn't sign into using Google. It just kept kicking me out again. It only wanted a boot from a 4K monitor, so in the end I abandoned trying to use Android. Reborn OS, which is kind of an Arch Linux friendly version of Arch Linux, is how they're kind of pitching themselves. That has a lot of potential. It does support the Rock 5B. I went through, booted it up, and it seems to have a lot of potential. I didn't go too far with it, but it only wanted a boot from a 4K monitor, even though I was connecting it to a 1080p monitor. Only wanted a boot from a 4K. So there are these annoying things. There are these bugs. You have the GPIO libraries where there are no libraries for Python. There are no libraries for C and C++. It's just these things that just is not quite as polished and as smooth as you'd get experience, for example, if you had a Raspberry Pi 4. As I said, GPIO support limited, no GPU acceleration, as I pointed out, no support for those hardware codecs. So again, just all these problems. Now, another thing to note is that not all USB-C power supplies seem to work. You're meant to be able to power it with any power delivery USB-C supply. I've got a few of them. I plugged one in, it just wouldn't boot. Certainly there was enough power, enough wattage. Plugged in another one and it worked fine. So it's a bit hit and miss. Now you can get an official power supply from radx, so that's possibly the safest way to go. But there's obviously some things that need to be worked out there. And finally, documentation. Great when it exists. As I said, I was able to get it booting off the NVMe drive. I was able to update the firmware, and everything was written down exactly as you needed to do. It was logical, it made sense, worked fine. Other places in the documentation, it's just placeholders. There's just like a title and no text. Nothing there at all. You don't know anything about it. You're just like, well, okay, tell me about the... Oh, I can't tell you anything about it. There's nothing in the documentation. So they've got to do some work on the documentation. So what does that bring us to the conclusion? Well, the Rock 5B hardware is excellent. There's just no way of putting any other way. However, the software is best described as a work in progress. So if you want to buy a plug-and-play solution, then get a Raspberry Pi 4. If you just want it to work, huge ecosystem, lots of great documentation, lots of libraries, lots of support, lots of different examples out there, just get yourself a Raspberry Pi 4. However, if you can't get a Raspberry Pi 4 because they're not available, or you need a better performance, you need that NVMe support, you want 2.5 gigabit Ethernet, and you don't mind fighting the software, then get a Rock 5B. Okay, so there it is. There is my overview of the Rock 5B. Please do tell me in the comments below what you think about the board. Are some of those limitations showstoppers for you, or the fact that you've got that NVMe storage that you can boot from, 2.5 gigabit Ethernet octa-core processor, do they compensate for the rough edges that you find in the software? I'd love to hear your opinion. Okay, that's it. I'll see you in the next one.